Okay, group, we're back to generators and alternators and things. 3 of my 11 subscribers apparently are interested in this not concrete house building. And since they was nice enough to make comments, we're going to try to see if we can explain some stuff to them here. This is the a configuration of the one we're building. Now, let me let's see here. We're going to click the magnets. Just find any magnet. They're all connected together. And pick a place where we can turn them around. Now, if you look up there at 12 o'clock, you see a red coil and a yellow magnet just about to come to it. And as it passes over the first part of this coil, the left side of the coil, I think it's Faraday's law. It's one of those guys. If you wrap your fingers around the coil, around the wires, in the direction that the flux goes, from the magnets, like from south to north, then your thumb points the direction of the current that it induces. Okay, as it passes that first side of the coil, see, just for argument's sake, we're not going to figure out lefts and rights because we're going to change this whole video into a generator rather than an alternator. And that's the trick. Okay, so if we assume that we wrapped our hand around from the top and our thumb was pointed down, that's the direction the current goes. Now, as that magnet comes over to the other side, the magnetic flux is still the same. And your thumb is still pointing down. But you notice the rotation of the current is now the opposite direction around the coil. So it's alternating current because it went from turning clockwise to turning counterclockwise. Does that make any sense? And that's what we're going to exploit in this video. And as this thing goes around, we can get it up here. There's 6 intermediate positions to get a magnet from one red thing to the next red thing. If you're running it as a motor, you have 6 positions. Okay, but we're not going to run this as a motor. We're going to do it as a generator. This device that we have drawn here could run an electric car. Be a really powerful electric car, but it's for a 20-some foot diameter, 7-meter whole house fan. Okay, we're going to go here to the subject of the video. It says make it a little bigger, not that much bigger. Okay, here's that red coil we were just looking at. It's got these 2 parallel sides. The space in between, the rectangular space here, that's the shape of the magnet. It's a pretty close fit on the magnet when you make a coil. You don't want it big and sloppy. You also want those straight sides to line up parallel with the magnet. If they're at an angle, they make less electricity. If they're 90 degrees to it, they make 0 electricity. So we're going to exploit that. We're going to look over here on the left. We have what I'm going to call, if you invent it, you name it. I'm going to call it a D coil. D as in dog. We have a straight side here. And it's going to, if it was on the thing we were just looking at, it would be sending current down by the right-hand rule. However, when that magnet comes over to the other side, it is not square with this side of the coil winding. Now, there's a section here from, I don't know, 8 or 10 degrees above 90 to 8 or 10 below, that some of it is lined up. After those angles, it probably produces absolutely nothing. But into that, in the middle here, you have a little bit of magnet exposure on something that is parallel. But there's very little reverse voltage. Because the magnet is in line with this, makes full power on that side. But over here, you're not breaking the magnetic lines of flux with the wire. Just barely. So that's the trick that's going to turn this into DC. We're making half of the wave. This little cutie here is a representation of what's actually going on. Okay. This is the voltage we will get when we do this. The top is the maximum voltage of a single magnet over a single side of a coil. Of course, it's times the 30 coils. It's not really that tall in one coil. But because it goes from basically 0 voltage to, in this case, 48 volts for all the coils, it's only part of the time high and part of the time low. And so you're going to get a root mean square voltage where the area under the blue line is equal to the area on the top of the blue line. Now, you're wondering why there's so many pulses all jammed together here. At least you should be. We have 30 coils. We have 360 degrees of rotation. That's 10 degrees separation on the coils. So, if we take our magnets, which are 32 magnets, they all pass that from one coil to the next in 10 degrees. They all, in a revolution, you would get this many little voltage spikes. Because we're connecting every one of these coils in series, not just every third one for 3-phase. This is going to be a single-phase permanent magnet generator, not an alternator, a generator. We have done away with all the voltage swings of the sine curve below the line. Yeah, that's an exaggeration. That little bit of it that does line up, if we have 48 volts, on the side we're trying to use, we might generate 3 to 5 volts on the other side. They're bucking voltages, and they're going to cancel out a little bit of as they pass over that one point. It's not really significant. Now, this is the same magnet rotor as we looked at before, and this has got the D-shaped coils on it. Now you'll notice that these D-shaped coils, the less you have this ever lines up here on the magnets. Oh, there's a magnet sitting right in front of it, and that magnet is just past centered on it. So you can see what percentage of that winding is anywhere close to line up with a magnet. It's very little. But if you was to make a triangular form to wrap your coil around and make more of a peak out here, like a V shaped, like a triangle shaped, then you'd have a lot less. I think it's harder on the wire trying to do that. And the only part that counts on this is when this magnet comes in front of that. Where is that thing we just did on the other one? I'm gonna take this. Find the center, please. Okay, we're looking at this magnet right here. As it comes over and it centers up on that, that's you're intersecting all the flux lines of that magnet with that coil. And then it comes over and it gets to the other side, and you can see that there's not much of the coil lined up with the magnet, so you're going to get very little power. Even though the current is going the wrong direction, there's not much of it. It's really biased the other way. So people like to see animation. We're going to call this animation just for the subscriber 5. He likes animation and animation. Now, because I've not actually built this is just trying to explain how one part of how alternators work. You've got magnets that are north and south, and you've got poles that make a positive voltage on one side and a negative voltage on the other side. V equals IR. The resistance is changing and everything is changing. Anyway, to make a 3-phase, you have 3 sets of coils You know, there's this is a blue, a green, and a purple, I think. And you connect every third one together to make a phase. So you have 3 phase from the from this coil here. It's 10 degrees to the next phase, 10 to the third phase, and then you're back to the same phase you started on, because it repeats. To simplify this thing, we're going to turn it into a generator. First thing we change is the magnets on the magnet wheel. Normally we have a north-south, north-south, north-south. You know, they're magnetized through the magnet faces, through the big faces. So the flux is pointed up and down. The down sitting on a metal plate, it goes through the metal plate. If it's a north face down, there's a south face on either side of it. So that flux bends and runs through the plate and comes up on the other magnet, which reinforces the magnets. They're stronger than the single magnet because they're interacting with each other. On the other side of then the stator sits on top of those magnets. The rotor turns, it rotates. The stator sits still because all the wires go to it. Then you have another plate. And if the magnet we're looking at on the bottom plate is south facing up, then the one on the other plate, which, you know, the plate's flipped over, but it'll be north facing down. So you have a south interacting with a north, every position. And also that you're boosting the magnetic Gauss because now it's not interacting with the plates, it's interacting with the magnets on the other side, pulling more of the flux right through your coil. So it's much more efficient with the two rotor plates than it would be with 2 stators with a plate each. Won't make as much power as you will with 1 stator, and the 2 plates are working on the same coils. Now, because we've got a little bit of back EMF on this thing, up here what we're looking at is that's the symbol I use when I have to make a diode on something. It's similar to the one electricians use. Basically, current can come in the funnel and out, but if it's trying to come the other way, it runs into this plate and it stops it. It's a one-way check valve for electricity. If we put a diode on each coil, like the wire coming out of that's the one that's not all wrapped up in something. Okay, over here. Here's the wire going into the beginning of wrapping the coil. That's your lead coming out. And you wrap it around and round and round, and then it comes out, and this is the other end comes out. It's on the outside of the coil. This one's on the inside, and that one will be on the outside, so you know which one you're looking at, especially if you start your coil in the middle here. You know, it's really easy to tell where that is. If you started both of them on this side, you may not be able to tell. Anyway, all these coils are in series. So there's no clockwise, counterclockwise winding on the coils. So my trick for finding out which ones are holding you back and which ones are going and shifting the rotations of the winding clockwise to counterclockwise to have nothing working against you, not needed here. All the coils are absolutely identical. The magnets, instead of being north-south, north-south, pick a configuration like all norths. Your whole one rotor, all the norths are facing up. Your whole other rotor, all the souths are facing down. So there's no confusion on which magnet is which. You don't have to worry about the alignment of the one rotor plate. The north magnet has to be above a south magnet on the other plate. Otherwise, the flux won't go through the coil at all. And if you have any one of those things wrong, you get heat. It just confuses them little electrons. It just ruins their vacation. So I put these diodes in here because this is not a project I'm currently building, but I put down my ideas. There's hundreds of things in this computer, but this is just one that I might do. I'm going to, the stator and all the parts that we got designed in here that we've showed on videos, they're all in production. We're actually building that one right now, except we're trapped in the U.S. If I was over there, I'd be assembling it. I'm working on the fan blade right now over here. I'm doing the hubs. That's a 3D shape of airfoil, and I'm doing that in my machine shop. And then I'll go out and make the blades out of styrofoam with a hot wire cutter and fiberglass all messed together. Anyway, The diodes are in here to get rid of that little bit of back EMF. However, they are also a point of failure. You've got 29 diodes on the 30 coils. And any one of them fails, that opens a circuit, and there's not a complete circuit through your stator. So I would advise, if anybody was to actually try to do this, I would bend these wires someplace here, bring them down to some point. Well, you could do it either way. Just make sure you have enough wire that you can swing it over and connect these together. If you were doing it without the diodes, you would put a little extra wire here and solder to the next one. If you wanted to put the diode in, you would stick it in that part right here. Anyway, the diodes are a failure point. I would try it first with no diodes. Basically, a ring of coils all the way around. Can't get no more simple than that. All the coils are the same. They're all connected the same rotation. The magnets are all facing the same way. You start in, you go through a bunch of coils, and come around eventually through these coils, you come back out. And that's your positive and negative for your generator. It would be a permanent magnet generator, not an alternator. There's no phases. It's not an alternating current. It hasn't got phases. It's a single DC output. If you put the diodes in there, it only generates power in one direction. Because the other way, the current would have to go through the coil and come back out the other wire, and it would hit the block on the diode, and it wouldn't go anyplace. So it's a one-way rotation. You would have to get that right. You'd have to have your fan blades or your vertical axis blades, plates, buckets, whatever you're using, would have to turn the right way. I believe you could flip the stator over upside down, and it would be going the other way, because the D would then face the other way. Makes sense to me, but like I say, I have not built this. So what have we learned here? We've learned that we've got rid of the negative side of the sine wave. We have a bunch of pulses, one from every time that magnet passes a coil, right? It makes a pulse of electricity. And to get from get one rotation of this thing, if you have 30 coils over here, you get 30 individual pulses. And after you get away from the start to where you're out in the middle of the thing, that first one's like where you would connect it. This voltage, while they're all varying and they're all added together, well, this is just all positive voltage what do you call it? They're all sine waves, half a sine wave, top half. But they're all the same. Like if it's minus on the bottom, plus on the top, that's what every one of them is, and they're additive because they're together. Actually, it's a pretty ripple-free DC in the end. Still you have the high voltage and basically zero voltage at the bottom. So the area under the bell of the sine wave is what's going to determine when it's equal to the top, and that's what you're going to get for voltage, minus maybe 3%. So is there anything else to say about this? We have let's go back over here again. This is more like random thoughts. In our alternator, this coil and that coil have to be wound in opposite directions. However, there's nothing to say that we can't make this D wider over to here and a really sharp point coming back, and you would have virtually no back EMF. You can make them and lay the straight edge of one on across the peak of the other one. If you take this thing, if you put an axle down the center of that, and you wrote that coil around that axle, you still have wires going parallel to the flux, and the magnet flux gets cut by the wires. So you could lap these things over. The stator's built that way. They have a few odd things about them. I don't use them because the gap between the two magnet plates has to be bigger. Or it seems to me that it has to be bigger. I just don't see how I can get enough wire, even in that bigger circle, to get enough ohms. Another thing, this DC generator deal, instead of having to use up all your ohms on 1/3 of your coils, you get to use all 3 of them. So the number of coil windings can be higher because you can use a smaller wire that's only 1/3 the amp capacity. It's not only that, it's cheaper, per foot. Anyway, you could lap these things over. I think they call that serpentine coil. I'm not sure. I've never built one of them, but I think they call it a serpentine coil. Anyhow, this is I'm just trying to explain how these alternators work. You're making a pulse. You're making a pulse on both sides of your coil. And because this wire goes around, if it's going down on that side, it's coming up on this side. Another item, if you're having trouble getting enough wire into your coil, there's nothing to keep you from running this coil wires out past the end of the magnet. You have to buy more wire. It doesn't get intersected by the flux, so and if it's round on the end, it goes back to as it's passing over. It's not really generating much because it's the inside is the shape of the magnet, so there's really no great amount of flux up here. But if the higher up you go, you can use up more wire in the coil to get more resistance for your to get your voltage up on your machine. And I had to go to this, and I went to the 2 mags because it just wasn't possible for me to get the voltage I needed and the amps I needed at the same time. I wanted a 48 volt fan with huge starting torque, so that I ended up putting another row of magnets and just making the coils twice as tall, but not really twice as much wire. Maybe added maybe 70% more wire to the coil. But I could, if I didn't make it, I could have gone this up even farther. I could have brought it up into here somewhere. Doesn't make any difference. It's not cutting. Magnetic flux is not cutting those wires, so they're just extra. Like it'd be like the wire that connects one coil to the one 3 over. You have a piece of wire up here, like I don't know anybody's. One of the 3 guys that looks at these videos, he's seen this thing before. This is this stator, because I have 90,000 pounds of magnetic force on this thing, some ridiculous number. I'm kind of afraid of those magnets, to tell the truth. I don't mind riding a motorcycle 200 miles an hour, but I just don't think much of being anywhere near these magnets. So I made the stator into 2 pieces, and this is where you connect the 2 pieces together. And it also lets me change all kinds of configurations about how many coils are in a series and whether I'm making 3-phase or 5-phase. It can all be changed right here with these jumpers around the outside. But if I take the jumper wires off, then I've got 2 half stators. I can slide them in between the magnet plates. And this is rigged up with my trick, where I have 2 coils clockwise. Let's see here. It's not drawn on this one. This is before I did it. Or else, actually, it's the same parts. If I take 1/2 of this stator and flip it upside down and butt it back together, that will put me 2 counterclockwise side by side, and 2 clockwise at the top end. This just happens to be drawn up this way, but the parts can be assembled or changed just by undoing some bolts in half an hour, something like that. It's just that You have to go up through those magnets. There's really not magnetic flux outside of it because my plates are so thick. They totally absorb the backside magnetism. It gets transferred side to side and then back through the gap. Oh, if you do this generator thing and you find out that you have way too much voltage, it's easy to dump voltage. It doesn't cost anything. You just jack your magnet plates farther away from the stator, up the air gap. Normally, I'm running a 2mm air gap, which is, you could put a couple pieces of paper in there and it wouldn't take them out of your hand. But you could open that up to 1/4 of an inch and have exponentially less voltage. And by the same token, if your voltage is low on your system, if you can crowd those things together, if you make them flat enough, like when you cast the epoxy on them, if it's between two pieces of phenolic board and some wax paper and stuff, you clamp the crap out of it and smash it flat, then you can run a lot closer. I don't recommend trying to sand off any more than a few casting bubbles and things, but because if you hit a wire, you can start over again. Anyway, this is showing how the one coil gets hooked to the next, and like if you follow the green wire, you can see where it goes through a bunch of stuff and it comes back out to another green coil down here. Anyway, the deal here is when a magnet, the flux of the magnet going from like south to north, when it passes the field passes these wires, it generates current. That's why a transformer works. It's changing flux. If this wheel was sitting still, it would generate no electricity. If you put DC on a transformer, nothing comes out the other side because you have to be changing the flux. And the way these alternators work is the magnet's getting closer to the coil and going away from the coil. That's where you're getting the flux changes, the movement of the magnet. The wire's sitting still, but the magnet is moving past the strands of wire. That's why you're getting current on this side of the coil when the magnet's here, and when it gets up to the other side, it's making current, and it's the same direction. But since the wire is a loop, it's now trying to make the current times resistance is voltage, V equals IR. It's trying to make a voltage or an EMF going the opposite way, so it's bucking it. And your object is that you want your magnet polarities and your coil polarities by which direction it's wound to maximize the amount of currents you generate. And how you connect them end to end makes a difference. I did a video explaining why I've got the two clockwise together, the two counterclockwise together. But just imagine you take this left side and flip it over, and it'll be up here, and what was up there will be down here. And then you'll have two together and two together. And at that point, I have basically two 280-degree motors, one running one right behind the other. But there's no clogging because it's both of them there. If I was to take one of them out of the system altogether, then probably would turn because you got enough to turn it, but it would definitely clog. Might knock the house down because this is a pretty big thing. Oh, that's the diameter of my plate that the magnets are on, 31.998, 32-inch plate for the magnet. So I don't know what size your generators and alternators are, but this is 32 inches. That ought to turn a 21-foot fan. And one last look down here. So we're doing away with having to have your magnets alternate on a plate. And we're doing away with having to have coils wound clockwise and counterclockwise or connected inside to outside and outside to inside. They can all be connected straight on through into one continuous loop. There's only one loop. Is DC. It's not a phase because it's the entire rotation, and it's just connected to the next rotation. So it makes only DC voltage. It makes 3 times the volts that it would if it was being run as a 3-phase, because you got 3 times as many coil windings in a series. 3 times as many coils. If they had the same number of winding wires, then, you'd have 3 times the voltage. And if you're charging batteries, they're DC. This would be DC. I don't see much advantage to forcing all these polarities have to match up. Another thing about DC, and I haven't done anything on it, but I need to, if I was to build this, I would check it out. If you're doing an in-runner or outrunner motor, like a model airplane engine, where the magnets spin around the outside of the coils, and the coils are pointed towards the magnets, then you have to have metal poles, because the magnetic flux is not being cut. It has to magnetize the metal pole, and the metal pole then turns the flux 90 degrees, and it makes a magnet. So you're making a magnet with electricity going into the coil, which magnetizes that metal piece in the middle of it, and you get a north and a south face on the magnet, but they're pointed towards the axle and towards the rim. So that matches up to the magnet in the rim, which is north and south. I'm going to post this video, though I think I may confuse more people than I help. But like I said, I'm into concrete house building right now. And this is just, I needed a fan in the house. And I priced them, and they were $15,000. I said, no, I don't think so. My guy that makes the middle grills can make this. So y'all have a nice day. I'm going to try to get this thing stuck on YouTube. Bye.